Everyone, welcome to Exademy Redefining Education. My name is Prabhash Kumar and I'm teaching you linear algebra. This is the first lecture of linear algebra. So put the heading linear algebra. Before entering into this linear algebra topic more in details, let me give you an overview of the term algebra. This algebra is actually an Arabic word al-zabr, okay, and it means reunion of broken parts. Reunion of broken parts. So what is this algebra? It is a mathematical tool. It is a mathematical tool having certain symbols and operations of these symbols lead to solution of certain problems. Okay, so I gave you a trivial definition for this algebra basically, and broadly speaking we can classify this algebra in two major categories. First category is your elementary algebra, and the second category is your abstract or modern algebra. Abstract or modern algebra. So what is this elementary algebra? The fundamental, the essential part of mathematics, okay, without which you cannot proceed. So this is the elementary algebra, and if you want to deal certain things in a more abstract manner, so those things are called your abstract algebra or modern algebra. So this is studying in the lower classes or for competitive exams, and this is basically as studied as form of advanced mathematics, okay, and the professional mathematicians study and follow this modern algebra. And if we talk about the competitive point of view, this is important for UPSC and state public services examination, and this elementary algebra is basically focused for GATE and other competitive exams, okay. And if we talk about a segment of elementary algebra, that is a linear algebra. So our focus in this particular course will be on this, okay, and I'll prepare a separate course for this modern algebra for UPSC aspirants, but for this particular course we'll be focusing more on this linear algebra part, okay. So what is this linear algebra? So this linear algebra deals with, I'm writing in short, so linear algebra LA deals with linear equations or linear functions and their representation in forms of matrices and vector spaces. Yes, this linear algebra is also a part of your UPSC syllabus. Okay, so I'll be covering from both perspective, from your UPSC perspective as well as from GATE perspective, whichever you are comfortable with. You stick your restrictions of your study to that, but I will be covering everything. So this linear algebra topic deals with the linear equations. That means the degree of the equation has to be 1. Okay, the linear functions and their representation in terms of matrices and vector spaces. So put the heading, what is a matrix? Matrix is nothing but an array of elements arranged in terms of in rows and columns. Okay, so it's basically a collection of elements. We arrange those elements in certain forms in terms of rows and columns. Let's say we have 2, 3, 4, 7, 8, 5, 1, 0, 3. Okay, and this big bracket you need to put. Okay, so this is called a matrix. A matrix could be like this as well, 2, 4, 5, 6, 7. A matrix could be like this, 1, 2, 3, 4, 0. Okay, so there could be different dimensions of the matrices. We will talk more in detail. If we talk about the generalized form, we can write, let's say a matrix, I am representing this A. Put this in big bracket, write a small letter A, write the subscript I and J. Okay, so what does it mean? And here outside I am writing M cross N. So understand this, what does it mean, and the different notations and the symbols. Okay, so this M cross N, so I'll call this as the order of the matrix. Order of the matrix. This I and J, they have separate meaning. This I represents the number of rows. Okay, the number of rows. And here J represents number of column. Number of column, or rather, to be more specific, you can specify, it specifies a particular row. And this specifies a particular column. Okay, and what does this A represents? It represents the element in ith row and jth column. Okay, ith row and jth column. This order of matrix is also called as the dimension of the matrix. The dimension of the matrix. So let's understand this with one simple example. So let's say if I write A 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3. Okay, so this big bracket represents that it's a collection of these elements, and this is the standard representation of a matrix. Okay, so this putting this big bracket is important, highly important. Fine, now let's pick up one element and let's see what does it mean. If I write a 1 1, I told you it signifies the row. This, the second one, signifies the column. So here for this particular element, I can say that this is the element lying in first row and first column. You know what a row is? This is called row. These are the rows, the horizontal lines. These are the rows. And what are columns? These are columns. So the vertical lines, as you can see, these are called columns. Horizontal lines are called the rows. The vertical lines are called the columns. So here, as you can see, here we have got first row, that means this first row, first column, so that means this part. Fine. If I select the second one, what does it mean? It means the element in the second row and second column. What is second row? This is my second row and this is my second column. How I am able to identify? I am starting from here and I am going here. I am starting from here and I am going here. See the direction of the arrows. Okay, so this is my origin point. I am starting from here and moving towards the right. So this is my first column. This is my second column. This is my third column. If I go like this, this is my first row, this one. This is my second row, this horizontal line, and this is my third row. So if I select this one, I can say this is my second row and this is my second column. So where is it intersecting? It's intersecting in the second row and second column. Similarly, if I select this, I can say that this is the element lying in the third row and the third column. So this is basically represented in a small representation is like this. Okay, so this is basically the representation of the matrix. How do you represent it? Okay, next we will learn the types of matrices. The types of matrix. There are multiple types of matrix, so we will pick up important ones, and as we proceed we will introduce some new matrices in subsequent lectures. First type of matrix, which is the fundamental one, is your square matrix. Square matrix means it will have equal number of rows and equal number of columns. So that is why it is called a square. You know that all sides are equal. So let's say if I write 1, 2, 3, 4, 5, 6, 7, 8, 9. So here I can write how many rows are there? 1, 2, 3. 3 rows are there. How many columns are there? 1, 2, 3. 3 columns are there. And since this is equal to this, I can say that this is nothing but square matrix. Why? Because here m is equal to n. The order is equal. Fine. So here the number of rows is equal to the number of columns, and hence we can say that this is a square matrix. In short, we represent, let's say, a matrix A. Let's say this is my matrix A. In short, I will represent this as Aij bracket close, and in the subscript, then in place of order, of course I can write either n cross n or p cross p or m cross m. So both these alphabets have to be remain same. Okay, so that is the meaning of square matrix. The second type of matrix is your rectangular matrix. Rectangular matrix. Here the matrix will look basically like a rectangle. Let's say 1, 2, 3, 4, 5, 6. Of course, this is looking like a rectangle, not a square. So let's find out the order. How many rows are there? 1 and 2. 2 rows are there. How many columns are there? 3 columns are there. Okay, so I can represent this. Moreover, if I write something like this, let's say a matrix A, again 1 2 4 5 6 7, can I call this matrix to be rectangular? Yes, of course we can call this matrix to be rectangular, because this is a non-square, and any non-square matrix is a rectangular matrix. What is the order? How many rows? 1 2 3, 3 rows are there. How many columns? 2 columns are there. So order is 3 cross 2. So in short, I can write the order or represent this rectangular matrix as big bracket Aij, and here I will write m cross n, but the only condition is that m will not be equal to n. Okay, so this is the standard representation and notation for your rectangular matrix. Let's proceed further. The third type of matrix, we call this as a row vector, or simply a row matrix. Okay, row vector or a row matrix. What does it mean? It means it will have a single row, that is say 1 2 minus 1 0. How many rows are there? Only one row is there, so I will write one row. How many columns? 1 2 3 4, so cross 4. Okay, so it should have a single row, that's it. How to represent it in the standard format? I'll be writing Aij, and the first subscript will always be 1, that is the number of rows is always 1, and this is, it could be anything, n could be anything, doesn't matter at all. So I'll call this simply a row vector or a row matrix. Second, we have a column vector, or simply a column matrix. How to represent it? It will have a single column, so let's say minus 1 0 5. So this is single column. And how to represent it? The order. How many rows? 1 2 3 rows are there. How many column? One column. So in short, I will represent this as A is equal to big bracket Aij, and it would be n cross 1. This n could be anything, but the number of columns has to be always 1. Okay, so these are some fundamental type of matrices. Moreover, write a note. So let's say I'm considering one matrix like this, and I am representing some elements inside. So let's say this is A11, A12, A13, this is A21, A22, A23, this is A31, this is A32, and this is A33. Okay, now you notice one thing, that the elements present in the diagonal. So first of all, I should mention that this diagonal is called the principal diagonal. The principal or the main or the leading diagonal. Okay, so this is called the principal diagonal or main diagonal or leading diagonal. Moreover, we have other diagonals as well. So this one, so this diagonal, this is also a diagonal, this is also a diagonal, this one is also a diagonal, and the last one, this one is also a diagonal. Okay, so rest other are off diagonals. Okay, so this is my principal or main or leading diagonal, and the rest of the diagonals are my off diagonals. Similarly, the elements present along this main diagonal are called the principal diagonal elements. So here you can say that this A11 is your principal diagonal element, A22 is also principal diagonal element, A33 is also principal diagonal element, and the rest other elements, which is A12, A13, A23, A21, A31, A32, all these are off diagonal elements. Is that clear? Okay. If that is clear to you, so let me show you one more interesting thing, the notation. So this is my principal diagonal. Okay, now the elements present on the top forming the upper triangles, just like upper triangle. So this is called the upper triangular elements. This is called upper triangular elements. So all the elements present here in this upper triangle are called the upper triangular elements. Similarly, all the elements present in this lower triangle are called the lower triangular elements. So these are called the lower triangular elements. Okay, so you should notice one thing, that for this is called the principal diagonal elements. Principal diagonal elements. If we talk about the relation between I and j, so you can say here for this particular diagonal elements, your I will be equal to j. Can you notice? 1 is equal to 1, 2 is equal to 2, 3 is equal to 3. So hence I equals to j. But here you can say that I is less than j. Can you notice? 1 is less than 2, 1 is less than 3, 2 is less than 3. Cool. Now here for this lower triangular elements, your I is greater than j. So as you can see clearly that 2 is greater than 1, 3 is greater than 1, 3 is greater than 2. Clear? So these are some important things that you should keep in mind. Next type of matrix we will see is a lower triangular matrix. Lower triangular matrix. What is a lower triangular matrix? So any matrix which is of this form, any matrix which is of this form, so let's say I have 1 0 0, 2 0 0, 4 1 2. Okay, so here the elements will be present in this lower triangular element like this. Let me show it with a different color. So as we can see clearly that the elements are lying within this lower triangle and the rest other elements are 0. Okay, so rest other elements are 0. So this is what? This is my lower triangle. Lower triangular elements. So if the elements apart from this lower triangular elements are all 0, I will call this matrix to be a lower triangular matrix. Okay, so in short I can write it. Let's say A is equal to, in symbolically form I can write Aij. Order is, let's say, m cross n is lower triangular matrix if, when we will call this to be lower triangular matrix, when your Aij value will turn out to be 0 when I is less than j. What do you mean by I less than j? I less than j means this part, this element, this element. Okay, so for all these elements have to be 0. Whenever your I is less than j, all the elements have to be 0. That is the meaning. The rest of the elements may or may not be 0, but all these elements have to be 0. Okay, similarly you can write number 6. We have upper triangular matrix. upper triangular matrix. Here the representation still remains the same, but in this case the elements will be in your upper triangle. Let's say we have the matrix like this: 1 2 4 0 3 0 0 0 7. Rather, I should write like this. Yes, let's say 7. Okay, so here as you can see clearly that this is my upper triangle, and all the elements apart from this upper triangle are all 0. Clear? So I can write, let's say A is equal to Aij. I will call this as to be my upper triangular matrix. In short, I have written upper triangular matrix if your Aij, that is your element, becomes 0 when your I is greater than j. That means for which all parts? Here I is greater than j, here I is greater than j, here I is greater than j. So for all these parts, these elements have to be 0, and hence this is your upper triangular matrix, because all these elements are your upper triangular elements. I will call these elements to be upper triangular elements. Okay, so this is my lower triangular matrix and upper triangular matrix. Next, put the heading number 7. What is a diagonal matrix? Diagonal matrix. Diagonal matrix is such a matrix in which there will be non-zero elements present. You can say let's say I have 1 0 0 0 2 0 0 0 3. So if you see the principal diagonal, this is my principal diagonal. So if all the elements apart from this principal diagonal are all 0, if all the elements apart from this diagonal means this element, this element, this one, this, rest all elements except these elements are all 0, I will call that matrix to be a diagonal matrix. So in short I can say, let's say A is equal to Aij. The order, let's say m cross n, is diagonal if the elements, that is Aij, becomes 0. When it will become 0? Whenever your I will not be equal to j. Your I will be equal to j where? Along this. Here I not equal to j, not equal to j, not equal to j, I not equal to j, I not equal to j, I not equal to j. Okay, so whenever I is not equal to j, if the elements are 0, I will call that to be a diagonal matrix. Next matrix we have is your scalar matrix. Okay, what is a scalar matrix? So let's say a matrix A we have Aij, whose order is m cross n, is a scalar. I will call this matrix to be scalar if Aij equals to 0 when I is not equal to j, but Aii is equal to k. So if all the principal diagonal elements becomes equal, I will call that matrix to be a scalar matrix. Clear? So it's basically a diagonal matrix itself where the diagonal elements are all equal. So you can simply write, let's say we have 3 0 0 0 3 0 0 0 3. So as we can see clearly that the elements present in the principal or the leading diagonal are all equal. Okay, so if all the elements are equal along the principal diagonal, This is of course a diagonal matrix, but at the same time I'll call this matrix to be a scalar matrix. Just a small modification inside, you can write number 9, an identity matrix. Identity matrix. This is also called your unit matrix. Unit matrix. Very simple. If all the principal diagonal elements are 1, so let's say 1 0 0 0 1 0 0 0 1. So here, as you can see clearly, that all the principal diagonal elements are equal and equal to 1. Okay, so if all the elements along this principal diagonal becomes 1, I will call such matrix to be identity matrix. So symbolically we can write, let's say A is equal to Aij order m cross n is called identity matrix. Identity matrix. I will represent this with I. Okay, so in linear algebra, this capital letter I represents your identity matrix. If your Aij becomes 0 when I is not equal to j, and Aij becomes 1 when I is equal to j. Okay, so these are certain types of matrices, or fundamental matrices that we have seen. So as soon as we come across some usage of the different types of matrices, we will learn all those different special types of matrices again in the subsequent lectures. Okay, so we'll continue this lecture in the next part. See you in the next lecture. Till then, bye bye.